3/4 and 5/8. So again, you ask yourself, so Ethan, so you're looking at my two numerators, that would be denominators in this way. Can I make my 4 into an 8? Absolutely. This is going to stay the same. What did I do from 4 to get to 8?
Times 2.
Whatever you do the bottom, you must do the top. Okay, so that'll be 6/8, and therefore 6/8 is larger than 5/8. Now, John, going back to what you said, could I just multiply and make them into 32? Absolutely. But if, let's say, I were to add this, then this would be that would be an improper, which is still being done, but for taking it step by step. Okay, so again, 32. Anybody know of another denominator I could have made other than 32 or 8? 16. Because 4 can make a 16 and 8 can make a 16. Those are going to be, this is your lowest common denominator that you could have made. The smallest one. Okay? I could have tried to see, I could have made them 4, but can I divide 5 in half?
No.
Okay? All right. What about 15 and 6? What is my common denominator that 15 and 6 can both make? Mr. Cook?
30.
Absolutely. What did I do from 6 to make 30?
Times 5.
Whatever you do to the bottom, you
Must do to the top.
15 to get to 30?
Times 2.
Whatever you do to the bottom, you
Must do to the top.
Okay, ladies and gentlemen, once again, this is solely based on multiplication. Yes, Mr. Stoker.
The number 2, couldn't you just easily see that?
No. I don't disagree with you, but I'm making baby steps because tomorrow, this is what you're going to see.
On what?
You can't easily just say 5. Yes, we know that 5, 6 is larger, but tomorrow you're going to see this problem. Okay? And you can't combine them when they're not the same. So, practicing that is also going to get you there. But yes, if it was a true comparison, yes. We know that 5, 6 is going to be larger. You're exactly right. But that's my intention is not going to the number sense of that. I feel like that should already be checked off on how you feel about and work with fractions. This is where I'm wanting you to work with. Okay? Questions, comments, concerns about how that's going to work? Okay. All right, go ahead and press pause. We are going to create common denominators. Okay, we're going to be creating common denominators while we are creating equivalent fractions. Okay? So for instance, you've got 1/3 and 2/5. Okay? 1/3 and 2/5. So if I were to draw this, again, drawing fractions is not what you need to do to truly compare them, but I'm just trying to show you. So I've got 1/3 and I've got 5ths. Again, I know that automatically they're not the same size, so that's why I do not want to rely on my drawings. Why we do this is to make sure that we all right, so here we go. So I can't say which one is bigger, because if I were to look at these and have these as pizza slices, so say that Austin has 1/3 and I have 2/5. Looking at them, they look about the same, but Austin put his 1/3 over here on my piece of pizza and make them a total piece. They're not able to do that. You can't put a medium size with a large size pizza and count them as the correct pieces. So I'm going to have to make them new denominators and split them up into new fractions, or what we call equivalent fractions, so I can talk to them apples to apples, because currently they're not apples to apples. One is in thirds, one is in fifths. make my third and my fifth into that I could be speaking, dare I say, the common language, making them apples to apples? What do they both have in common? What number are they, or what multiple do they have that matches? Gabby?
1.
Okay, but can I change a 3 into a 1? So that's more of a factor. I do?
Yes.
1, 2, 3, 4, 5. Ah, okay. Thank you, and I'll just.
Isn't it like impossible to make a 5?
No, you can have. No, that's not impossible. You can cut anything into fifths. Reagan.
30.
Okay, 30. Is there a number that's even smaller? Think so. I guess better yet, let me do it this way too. You can ask yourself, can I make my 3 into fifths?
No.
No. So then let's go with my fifths and let's go multiples. 5. Can 3 make a 5?
No.
What about 10?
No.
15?
Yes.
Oh, there we go. So I would change my fifths and I would divide each of these 3 times. To make them into 15ths. And so I can change my 3 into 15ths. How many times did I split each of these?
5.
5 sections. Again, drawing is not adequate and precise for the obvious reasons. Look at my pictures. Okay? But nevertheless, I now have the same common denominator. Okay? What did I do from 3 to get to 5?
Times 5.
Whatever you do to the bottom, you
Must do the top.
Therefore, 1 times 5 is
5.
5. What did I do from 5 to 15?
Times 3.
Whatever you do to the bottom, you
Must do the top.
2 times 3 is
6.
so 5 15ths, 6 15ths, we would say is larger, or we could say 2/5 was larger than 1/3. Even though the pictorial representation I poorly drew didn't look that way. So you're asking yourself, how can I make them, and what denominators could they have in common when they don't have them in common to begin with? But all I'm saying, what do we say about the relationship between 1/3 and 5/15? What do we call this? What did I make?
Common
denominators. So just these themselves. Yes, we all make them common denominators, but the relationship of these versus these. What is 2/5 and 6/15?
Equivalent.
Good. Equivalent. Which is a fancy word for what?
Equal.
6/15 is the exact same as 2/5. All right, let's do another one. 7/9. And we can even compare them. Let's try this one and comparing them. 7/9. Is it greater than, less than, or equal to 1/3? So again, pictorially, again, a poor demonstration, but nevertheless showing you. You never want to draw and compare, because your pieces are not ever going to be. Okay, so looking at my denominator that I have currently, looking at my smaller one, can I make my smaller one, my 3, go into a 9?
Yes.
Can I make my 3 into a 9? Can I make my 3/3 into 9?
Yes.
Okay, so how can I make my thirds into 9?
Times 3.
Times 3, so I can split them up 3 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Absolutely. So I would say 7/9. This is my 7/9, and it's no longer 1/3. What has it been renamed to? Well, what did I do? 3 times 3 is 9. Therefore, 1 times 3 is 3. So really, this is the same thing. 3/9 is the same or equivalent to 1/3. And I did nothing here. So which one is larger, 7/9 or 1/3? 7/9. Again, comparing fractions, they were not apples to apples, making them apples to apples using the our common denominator. All right, so now I'm giving you the number here. 2/3, 3/4. Are these cut at all alike? No. I cannot put a 4th and a 3rd together. I cannot put a 4th and a 3rd together. So I'm going to have to figure out how can I separate these or cut these even more that they're able to cut and be cut the exact same way in the exact same amount of pieces. So I'm asking myself, looking at my thirds, can a 3 make a 4?
No.
No. All right, well, let's go with my multiples of 4. So 4 times 1 is 4. 4 times 2 is
8.
Can a 3 make an 8?
No.
What's 4 times 3?
12.
Can a 3 make a 12?
Yes.
So that means that both of them, excellent job, ladies and gentlemen, both of these now can be made into 12s. So let me originally color my 2/3 and then my 3/4. Okay? So what would I separate my thirds into? How many times would I make my thirds?
4.
Good. And what would I separate each of my fourths into? How many times?
3.
3. Or 2 lines. So now this one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now am I comparing apples to apples? Comparing the same numbers. So what did I do to get from my 3 to my 12, ladies and gentlemen?
4.
Good. Times 4. Whatever you do to the bottom, you.
Do to the top.
Therefore, 4 times 2 is
12.
8. What did I do from 4 to get to 12?
Times 3.
Whatever you do to the bottom, you.
9 to the top.
Believe it or not, originally 2/3 looked a lot smaller than 3/4. But when I'm talking apples to apples and they both are into 12s, there's only one slice difference. Okay? One slice difference. All right? Here we go. Five sevenths and 3/5. Can I compare them as is? Can I compare a 7 to a 5? No, but real quickly I'm going to look back at something. I could compare a 3 and a 5, but can I compare a 15 and a 15?
Yes.
Absolutely. So because these are not what I would consider comparable, or what we say apples to apples, we need to make them comparable or have common denominators, creating equivalent fractions. So looking at my lowest number, can 5 make a 7?
No.
No, it cannot. So let's look at my 7. Let's go my multiples of 7. What's 7 times 1?
7.
7. Can a 5 make a 7?
No.
7 times 2?
14.
Can a 5 make a 14?
No.
7 times 3?
21.
Can a 5 make a 21?
No.
7 times 4?
28.
Can a 5 make a 28?
No.
7 times 5?
35.
Can a 5 make a 35?
Yes.
How do you know a 5 can make a 35, Jaden?
Because 5 times 7 equals 35.
And not only that, what, Jaden?
Because it ends in a 5.
It ends in a 5, therefore we know it's divisible by 5. So my new denominator is 35. Please figure out what my two new numerators will be.
Can or cannot just multiply
Okay,
the
we're going to talk about that.
bottom
We're going to talk about that, okay? Emma, what did I do from a 7 to a 30 to get to 35? Whatever you do at the bottom, you.
To the top.
What's 5 times 5?
25.
Jason, what did I do from 5 to 35?
Times 7 by 3.
7, and therefore, whatever I do at the bottom, I must do to the top. 7 times 3 is 21. What is larger, 25/30ths or 21/35? Excuse me, 25 over 35 or 21 over 35?
25 over
So
35.
therefore, 5/7 is larger. We're going to talk about what you just said, okay? All right, so 3/4, this is how I want you to do by yourself, into, 3/16. 3/4 into 3/16. So do I have apples to apples? No, I do not. I need to make them with a common denominator. Cassie, what did you make your common denominator?
4.
Okay, so could you, hang on a second, this is a good point. Excellent, Cassie, I really am glad you said that, okay? 4 3/4 would stay the same. Can 16 make a 4?
No.
Absolutely, no it can, absolutely, why?
Because
Divided by 4, right? Whatever you do to the bottom, you,
Must be to the top.
can I divide 3 by 4?
No.
Okay, so therefore that's why that won't work. There's some times that you will go and you will divide. But good job, Cassie, seeing the relationship between 4 and 16. Mr. Cook, what can 4 or 6, what am I doing to denominators?
16.
Sure, 16. I didn't change anything. How many times did it take for me to 4 to go to make 16, ladies and gentlemen?
4.
Times 4. Whatever you do to the bottom, you must do to the top. Okay, here's something. I'm going to throw you a kicker here. Somebody in my last class said 32. Somebody in my last class said 32. Is that fair? Can this be done?
Yes.
Okay. Tell me some reasons why it can be. So going back to my original fraction, did I do something from 4 to get to 32? Xander. Whatever I do to the bottom, I must do to the top. 8 times 3 is 24. 16 times what got me 32?
2.
Times 2. Whatever you do to the bottom, you.
Let's do the top.
Therefore, 3 times 2 is 6. 24 is larger than 6. 12 is larger than 3. 1/4 is, ooh, that's why I just wrote on there. Okay? So, either way, your answer is correct. Okay? So, John. So, those didn't hear John. Because he said originally, well, can't you just multiply your two denominators? The answer is yes. But I'm going to show you something here in a minute. I'm showing you this recreating and making new denominators because tomorrow you're going to be adding and subtracting them. Okay? So watch this. Let's just say for all intents and purposes that I was adding them. Okay? So let's just say I was adding these answers. So I would add 12/16 plus 3/16 to be 15/16. And 24 plus 6 is 30 over 32. One of those is in simplest form. One of those is not. Using my 4 rules we talked about Friday, one of them is in simplest form and one of them is not. Gracie May, what do you think? 15/16 is in simplest form. What rule is that? Jaden?
The one away.
The one away, or what's that fancy word we use for one away? Consecutive. Good job. So this is consecutive. Now, is this wrong? Can I still simplify this answer? It's even, so they're both still divisible by 2. Therefore, that gets me the 15/16. It's still right, but when you're multiplying and you're just, like, there's nothing wrong if you were to pick 16ths as your denominator. There's nothing wrong if you would have picked 32. But the problem is, once you get into these higher numbers, you're going to end up having to simplify at the end. So that's why the 16th is the better option. 32 still totally works. But the problem is you're probably going to have to simplify or reduce at the end because you don't have your answer in simplest form. So if you pick a lower number like 16, you're just going to have less legwork, if any legwork, at the end. You pick 32, which is still correct, because can I make equivalent fractions with 32 as my denominator? Absolutely. It's still going to work. It's just you're going to have to divide at the end. Okay, or what? Divide because you're simplifying. Okay? All right, questions, comments, concerns. I'll give you 2 examples, and I want to see if you can do it yourself. Or give you 2 things I want you to practice yourself. You should have seen this last year. So hopefully this is not absolutely brand new to you. If it is, you're going to continue working on this. Tomorrow I will have a video that you'll be working independently or back at my back table on this, but I just wanted to give you an understanding of what you're doing tomorrow when you're recreating new fractions. All right, 3/4 greater than or equal to 5/8, as well as 2/15 is greater than, less than, or equal to 5/6. Okay, stop.